Okay, kids, this video is particularly helpful if you're trying to graph some logarithmic functions. Okay, oops, that's the wrong one. I want this, graphing logarithmic functions. Okay, so it's important to understand that logs are related to exponents, right? Logs and exponents are inverses of each other. Believe it or not, they are. So the way we graph inverses is you simply switch the coordinates from your one graph to the other graph. Okay, and that's what we're going to do. We are never going to graph a logarithmic function directly. We are always going to graph the related exponential, and then we're going to plot the points by switching your x's and your y's. So let's do that with our parent function. Parent exponential, y equals 2 to the x. Okay, so hopefully you remember that if we have every x value, then we're going to do 2 to the x value. Okay, so all we're doing is we are replacing x, so we have negative 2. Okay, if you plug negative 2 into your equation, we get 1/4. Right, we have negative 1 for x. You plug that, 2 to the negative x is positive 1/2. What if x is 0? Then we have 2 to the 0, which is 1. What if x is 1? That's 2 to the first power. 2 to the first power is 2. And then if x is 2, y is 4. Okay, so these are your coordinates that we graph from y equals, bless you, y equals 2 to the x. Okay, so let's see, that has an intercept here, right? There's some things about here that we should know. There's your point here, there's your point there, right? Some other things. This has a horizontal asymptote through y equals 0, right? All exponential graphs have horizontal asymptotes. So the graph starts off close to the horizontal asymptote on the left, goes through your y-intercept, and then grows exponentially to the right. Okay, so some things about this. The domain is all positive values. No, it's not. The domain is all reals. There is no restrictions on your x's. Your range, on the other hand, is only positive values, right? From 0 to infinity, not including 0. It's never going to be 0. It'll be really, 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 really close to 0, but we're never ever going to have a y value of 0. And this graph has a horizontal asymptote at y equals 0. So now let's make a table for the logarithm. Okay, so we have x and we have log base 2 of x, right? We have a log base 2 because your exponential has a base of 2. So that's why these guys are related. They're inverses because they have the same bases. Now, the way we graph inverses, normal inverses, is you take your x values from here and you make them into y values. And you take your y values from your original graph and you turn them into x values. Right? So I'm not going to ever evaluate a log of a certain base. I'm just going to use my previous graph in order to write down the coordinates. So let's do that. Now that we have all of our points on our table, let's plot them on our graph. So 1/4. 1/4 is, of course, less than 1. So 1/4 maybe is right here. So 1/4 comma negative 2. And then 1/2 comma negative 1. And then 1 comma 0, right? This is our important point. That's your x-intercept. This is the one we're going to plot all the time. Okay, and then we have 2, 1, which is right there. And then we have 4, 2. Okay, so our graph, our logarithm graph, is going to start close to your vertical asymptote, close to your y-axis. It's going to come all through these points. It's going to hit your x-intercept. And then it's going to grow logarithmically, right, which is much less steep than an exponential growth. but it has a vertical asymptote at x equals 0. Okay, we're never going to have any negatives in our logs. We can't take the log of a negative. So our graph for our log base 2 looks like that. Log base 2 is like this. So let's talk about some things. How about this one's domain? It's 0 to infinity, which if we look at 2 to the x, that was the range, right? And of course the x's and the y's switch, which means the domains and the ranges switch. So the range for our logarithm is all real values. We can get every single negative, we can get every single positive, and we can get all the fractions in between. And this one has a vertical asymptote at x equals 0. Okay, so these are all of the inverses, right? When things happen to be inverses, all of their x's and their y's switch. So that's exactly what we see happening here, is our x's and our y values are switching. Okay, so that's the graph of our parent function for logarithms, log base 2 of x. Okay, so let's see what happens with some transformations. So let's look at this. Right, this is our first transformation, and what does the x minus 3 in parentheses do for pretty much every algebraic function ever? Well, it moves our graph, shifts it 3 units to the right, and that happens the same thing here, right? Your parentheses means that your x value is always the opposite of what it should be. Okay, so how we do this is we, of course, draw in your x and your y axis if you don't have an x and y axis already drawn for you. And you first move your vertical asymptote 3 units to the right. Okay, so we put 3 tick marks on there, and then you draw in your vertical asymptote. Now we go to plot your x-intercept points. That's the second thing that we need to do, plot your x-intercept points. Okay. Your x-intercept is always 1 unit away from your vertical asymptote. And since it's a positive logarithm, that's going to be 1 unit to the right of your vertical asymptote. And for me and my class, my students, this is the only thing I need to see on their graph. Of course, with the graph. So the graph would hug your asymptote on the left as it comes up, go through that point, and then it would curve off to the right and grow logarithmically. So some other things to calculate would be the domain, right? We can calculate the domain of this by setting your parenthesis thing greater than 0. So x minus 3 has to be bigger than 0, right? Because we can't take the log of a negative. So we want to ensure that any number we plug in there needs to make sure that the that number is not negative. So the domain has to be bigger than 3, which as an interval would be from 3 to infinity, if that's the way you need to write it. Okay? So to find the domain, we always set your parenthesis thing greater than 0, right? It cannot be negative. You cannot take the log of a negative number. So we have to make sure to restrict any value that would make that negative. Negative 2, positive 2, 0 makes it negative. All those things are restricted. They are not included in your domain. Okay, so a horizontal transformation happens inside of your parentheses. Okay, so let's see what a vertical transformation would look like. So here we have log base 2 of x minus 2. So notice the minus 2 is not in parentheses. Okay, sometimes you might see this out front like a negative 2 plus the log base 2 of x. Right. Anyway, you might see it in front. Okay, so your vertical shifting either comes in front of your logarithm with a plus, or your vertical shifting comes after the logarithm, after your parentheses. So there's parenthesis x. And this, of course, moves your graph down 2 units. Down 2 units. So if we have your axes on here, there's your axis, right? First we plot your vertical asymptote, just like that. Okay, that's pretty standard. Without any left or right shifting, you have a vertical asymptote through x equals 0. Okay, and now we're going to plot your x-intercept. Now the x-intercept is usually 1 unit away on the x-axis, but we have moved ours down 2 units. So our x-intercept, quote unquote, is going to happen right here. Still 1 unit away from your vertical asymptote, but 2 units down from your x-axis, okay, which is why I put x-intercept in parentheses, because it isn't always where it crosses your x-axis. But that's where the original crosses the x-axis, and that's the point that I want you to plot. So that's what our graph would look like. Move down 2 units. Okay, so for the domain, nothing changes about the domain. It has to be bigger than 0, right? There's nothing inside of your parentheses with x to solve. So you just set x bigger than 0, and that's your domain. Right? No negative values allowed. Okay, let's look at some reflections. Okay, how do we do the 2 reflections with our logs? So one way is to get your x to be negative. Okay, so anytime the x is negative, remember that's a horizontal. The x is your horizontal axis. Negative x is a horizontally affected thing. Makes a lot of sense. So this is a y-axis reflection, because everything on the left side of your graph is going to end up on the right side, and vice versa. Right? That's a horizontal shifting, so that is why it's a y-axis reflection. So let's see what that looks like on our graph. So everything that was on the positive side, which is pretty much the whole entire graph, right? So the whole entire graph looks like this. So everything over here is going to end up on the left side. So our graph is going to open and point to the left, basically. Okay, so we still have your vertical asymptote, right? That still goes through your x equals 0. Your y-intercept is 1 unit to the left. Since our graph is opening to the left, your y-intercept is also to the left of your vertical asymptote. Okay, so then the graph starts on the left side of the vertical asymptote, hits your x-intercept, and then grows logarithmically to the left. I mean, technically our graph is coming this way, right? Because as x's get bigger, x's get closer to 0, your graph always moves from left to right. Right, so even though I say it opens to the left, it's really progressing to the right and going down for your graph. So in this case, if we took your domain, right, whatever's in parentheses, negative x is greater than 0, okay, because negative x is what's inside of your parentheses. So to find the domain, you take whatever is in your parentheses and you make it bigger than 0. Well, now we have to divide both sides by -1, right? So when we divide by a negative, what happens to the inequality? It switches. So as you can see, our domain goes from -infinity to 0. So let's look and see what happens when we have a x-axis reflection. There we go. So this would be like a y equals negative log. So the log is in, the negative is in front of the word log. Okay, so this is how we know it's going to be an x-axis reflection, because all of your y values are becoming negative. So everything that's a positive y value, everything above your x-axis is going to become negative, and everything below your x-axis is going to become positive. Okay, so here we still have your x equals 0 vertical asymptote. We still have your intercept at 0, 1, right? Nothing changes with that point, because the negative of 0 is still 0. But our original graph, right, log base 2 of x looks like this. So everything in the top part of our graph is going to go on the bottom, and everything on the bottom part is going to go on the top. So our x-axis reflection ends up looking like this. Okay, and it grows logarithmically, but in the negative direction. Okay, still a negative. So our domain is x is greater than 0, right? Because x is the only thing in our parentheses. So all the positive values of x. Okay, so a negative graph, an x-axis reflection has the negative in front of the word log, and a y-axis reflection has the negative in the parentheses with the x. So I hope this has increased your knowledge about how we graph some logarithmic equations, and you feel comfortable enough to do all of your homework tonight. Okay, that's all. Goodbye.